Hello everyone, I am Dr. Rajesh, and in this video lecture we will study Converse of Lami's theorem. So in the last lecture we have studied the Lami's theorem and also did its proof. So now in this video lecture we will study the converse of Lami's theorem. It states that if three coplanar forces acting at a point are such that each force is proportional to sine of the angle between the other two, then forces are in equilibrium. Let us take the forces acting at a point. This is one force, second, and in this direction this is the third force. Fine. And let us name them P, this is Q, and this is R, and these are acting at a point O. Forces are concurrent and three coplanar within the same plane. Fine. Now these are the coplanar forces and acting at a point O. Now we are given that this is the given condition. Each force is proportional to sine of the angle between the, like this force, sine of the angle between this one and this one. Say this is P, so to maintain the symmetry I am going to assume this as alpha. This is Q, so once again to maintain the symmetry I am going to assume this as beta. Fine. This is R, so to maintain the symmetry I am going to assume it gamma. So given condition is each force P is proportional to sine of the angle between other two, that is sine of alpha. Similarly Q, sine of the angle between R and P, which is beta. This is beta. Fine. R, sine of the angle between Q and P, which is sine gamma. Fine. And this is the given condition. And we are required to prove forces are in equilibrium. Look over here, we have to prove forces are in equilibrium. So you will be writing in the examination like we have three forces P and Q acting at a point O and making angles alpha, beta and gamma between QR, R and P and Q respectively. Fine. And this is the given condition you will write, and we are required to prove this one. And we know that three forces acting at a point, coplanar forces acting at a point, can be represented by the sides of the triangle. So let us try to donate these forces as the sides of the triangle. So let me draw the side parallel to this one. So the side parallel to this one. Say this is the side. Now side parallel to this one. Done. And the side parallel to this one. Fine. And let us name them as A, B, C. So this can be done. But to prove them in equilibrium, these sides, this side and this force must be in proportion. So we will try to prove that. If we are able to prove that the sides taken parallel to the forces are in proportion to the magnitude of the forces, then we are done. Then we are able to prove the equilibrium by triangle law of forces. So let me first try to establish some angles over here. This is in the direction of P, so this will be taken in this direction. This is in the direction of Q, so this will be taken in this direction. This is in direction of R, so this will be taken in this direction. Now let me locate the angles over here. Angle between P and Q. So this is, so instead of writing exact the, we are just donating the sides. Fine. So here you see this side and this side. This is converging, this is diverging. So I have to extrapolate so as to make it diverge from the point. Fine. So and we know that this angle is given as, this angle is gamma. So over a line whole angle is pi, so this will be pi minus gamma. Fine. Similarly this and this is converging, this is diverging, so I have to extrapolate this one. Fine. And this angle is alpha. This angle is alpha. So this angle would be pi minus alpha. Done. Now this and this is beta. Fine. So I have to extrapolate it. Done. And this angle is beta. So this angle would be beta. So this will inside will be pi minus beta. Fine. Now look over here. Let me use the sine law in triangle. Sine law in triangle ABC. So P corresponding to P, side taken parallel is BC. So firstly I am to maintain the symmetry and taking BC upon sine of the opposite angle. Opposite to this one is sine pi minus alpha. This is equal to, next is Q, this is Q, CA. So CA, this you have to take CA, it will be sine, opposite is sine pi minus beta. And next is this one, ABR, AB. This will be opposite to AB is sine pi minus gamma. Fine. So this will be, and we know sine pi minus alpha is sine alpha. Similarly CA sine beta, AB sine gamma. This equation is equation number 1. This equation is equation number 2. Fine. Now what you will do? You will divide 1 by 2. What you will get? P by sine alpha BC upon sine alpha is equal to Q upon sine beta BC, sorry, it's CA upon sine beta is equal to R by sine gamma AB by sine gamma. This will cancel out, this will cancel out. So we are left with P by BC is equal to Q by CA is equal to R by AB. Now the triangle which we have drawn is such that now we are in a position to say that is such that the sides taken parallel to the line of action of the forces are in proportional to the magnitude of those forces. Like BC is taken parallel to P, so BC and P are in proportion. P by BC, this proportionality is equal to Q by CA, R by AB. So this is proportional. So therefore by triangle law, if we can draw a triangle with proportionality of the sides with the magnitude of the forces, then by triangle law we say that forces P, Q and R are in equilibrium, So that we have proved that forces are in equilibrium. So thus we have proved that if the force is acting at a point, three coplanar forces acting at a point are such that each of the force is proportional to sine of the angle between the other two, then forces are in equilibrium. So what we have used in the concept, we have drawn firstly a triangle. And drawing a triangle, I am again emphasizing the fact that drawing a triangle does not guarantee the equilibrium unless we have the proportionality of the sides with the magnitude of the forces. So up to this point, this proportionality is not established. So any triangle can be any three forces acting at a point can be represented by the sides of the triangle, but that representation has to be in proportion so as to for them to be in equilibrium. So up to this point we are not sure that whether they are in equilibrium or not, because we just have taken the sides parallel to the line of action. That does not guarantee forces. One of the force could hugely dominate, and these forces it is quite possible are not in equilibrium, but they still could be represented by the sides of the triangle. So that does not guarantee anything up to this point that forces are in equilibrium. So we have just taken the sides of the triangle parallel to the line of the action of the forces. Up to this point we have not established an equilibrium using the sine law. Then at this point, when we have got the proportionality ratio of the sides with the line of action of the forces, so at this point we are sure by triangle law that the forces have been represented by the sides of the triangle taken in order, and such that the sides are representing the direction and magnitude in the proportionality ratio. Sides direction is represented and magnitude is represented by the proportionality. So that is what triangle law is all about. If the three forces acting at a point are represented completely in magnitude as well as in direction by the three sides of the triangle taken in order, then those forces are in equilibrium. So now we have represented the forces completely in magnitude as well as in direction. When we draw this triangle, up to this point we were only able to represent the forces by the sides of the triangle only in direction, not in magnitude. But when we establish this one, so we have represented the magnitude by the sides of the triangle, and that magnitude in the proportionality ratio. So the triangle law over here is justified, and that with that triangle law we can say that forces P, Q and R in equilibrium, and this establishes the converse of Lami's theorem, that forces are in equilibrium. So that is important theorem, so you should go through its proof thoroughly. And that is all I have from this lecture. And if you have liked the lecture, please like, subscribe, share and comment. This is Dr. Rajesh saying goodbye, take care, bye bye, and see you soon.